Hey, so I'm just going to introduce everybody to a new shader that I'm working on. This is very, very, very early, of course, but I have most of the shader laid out, except for the last fourth layer that I'm still working on. I'm doing proof of concept first. So what I'm doing is I'm allowing macro texturing of large surface areas on hard surface type objects with normals that are calculated not by baking but by averaging the normal weight across the surface. This is called medium poly modeling. There is no baked normal. So basically, the workflow for what you would have to do is you would use the chamfer in whatever program you want, and then you would run a script that averages the normals and makes that edge feel nice and soft while only having one bevel instead of needing holding edges. This is a much cheaper way to work on hard surface stuff, and there's not really been a shader in CryEngine that allows you to work this way without having a lot of separate textures to maintain your texel density. So what this is essentially there's no baked normal, so as you can see there's a layer 1, a layer 2, and a layer 3, all of which can have shared textures. So the point of this is basically you could have a multi-material with, say, like 6 or 7 materials in it, and with all of your other baked information in the RGBA mask. So this mask supports up to 4 layers. It is basically it's a combination of different hold on. There we go. Alright, so if we look at the channels, we have the paint layer, the rust layer, and then a dirt layer. I'm working on incorporating the 4th layer for the dirt right now, but results so far have been pretty exciting. I've added a couple of features that I think is really useful. For instance, I have this detail bump map that is applying to everything equally, so it looks kind of weird and has discontinuity between the materials. So I incorporated a slider here with 4 options basically. 0, it affects everything. 1, it affects just the layer 1 of the shader. As you can see, it's only affecting layer 1. And then 2 is layer 2, and so forth. So in the end, you'll be able to match it to just the 4 layers that you want. Whichever one, each one you want. I'm working on a way to combine them together by adding all of the numbers that you need. So if you want layers 1 and 2 to have it, then that'll be, 1 and 2 together is 12, so that'll be 12, 13, 14, etc. And then that way you'll be able to apply it to whatever combination of layers you want, and the cost will be the same either way. I have this sufficiently laid out in code so that it doesn't duplicate any sort of processes. It's using just the same process as everything else, so you don't increase shader complexity by using any of these options. For instance, 0 will be no more expensive than 24 if you want it to be on layer 2 and 4. For now, I'm just going to leave it on layer 1, though, because that's what I want. Furthermore, you have separate controls for smoothness. There's an option here. So as you can see, this isn't really doing anything yet, but you can choose to derive maps. And what this does is it takes the information from your second layer diffuse, and it will create the glossy surface for you, and it's controlled by the UV scale of your entire layer. So if you change the layer here, oh, wrong one. Here we go. The glossy surface changes with it. So it's like a detail layer, but not really, since this is still based on this mask. Each layer also has the ability to adjust the mask strength, so you can chew away or make even sharper these edges. I actually have built a function in code to create a normal map differentiation between the layers. So you'll be able to add like a little bit of normal edge between the layers. It's basically taking the grayscale information in your RGBA mask, and it is turning it into a false normal to create separation between the 2 layers. That I'll be showing some other time. But yeah, if you don't want to do that and you want to save a few calculations, or you don't need to derive the glossiness, you can just disable derived maps, and the glossiness will be controlled by the slider as a multiplication or as a whole using this slider here, like a normal shader. That's what I have so far, and I'm going to have two different versions of this. I'm going to have a version that's optimized, which is built to basically work off of only your diffuse. So you have a diffuse for each layer, and you have your RGBA mask, and then the normals, the specular, and the glossy will all be created from just those layers of diffuse textures. We can still get a really, really good result, a PBR result, even, just by using all these functionalities in here, and most are just single parameters, so they're very, very cheap in code. I'm using a lot of flow logic to make sure only the stuff that absolutely has to compile compiles. So this will be very efficient, about as efficient as base Ilum is, since I've cut so much of the core code out of it. So yeah, that's the introduction to the hard surface shader. Probably by the end of the week, I think I'll have this mostly done, wrapped up. So thanks for watching.